In this video, we're going to talk about solving rational expressions. In the last video, we were doing rational expressions and we were simplifying them. In this one, we're going to solve them. Let's take an example like this. 3 over a minus 6 minus 4 over a equals 1 over 2a. And what you're looking to do is to try to cross things out to solve. Now, if we look at it, they don't have the same denominator, so the main denominator is going to be a minus 6, a, and 2a, but 2a has the a in it, so you have to do that. So basically what you're going to do is you're going to multiply this first one by a minus 6 and 2a. When you multiply by a minus 6, there's an a minus 6 in both places, so that goes away. That's going to simplify things for you. On this, you're going to have a 2a and a minus 6. The a is gone, so 4 times 2, that's 8, so we'll fix that in a second. And this is going to be a minus 6, 2a, and the 2a's are gone. So what's left? You have 6a minus, there's nothing on the bottom, they're all marked out. Multiplying through, that's minus 8a plus minus 8, and minus 6 is plus 48 equals a minus 6. So I want the a's together, so putting these together is minus 2a plus 48 equals a minus 6. Move that a over, that's minus 3a equals minus 48. That's what, 54? Divide by negative 3, minus 3, and so a equals 18. And if I wanted to, I could go back and plug that 18 in. 3 over a minus 6 minus 4 over a equals 1 over 2a. I can put the 18 in there. So 3 over 18 minus 6 is 12. Minus 4 over 18 equals 1 over 36. And I can actually put all that together and I will prove that both sides are equal. But that's not what this part's about. You're not going to have the timing to do that, but you'll notice what I did at each of these questions, or each of these, is I was able to mark something out. Let's try another one real quick. Let's say I had one like this. 12 over x minus 3 equals 2 over x plus 9. Well, all of them need to have an x, okay? And so if I go ahead and multiply out, what I want to end up doing is multiplying by x in each of them. X is gone. X is gone. And so when I solve it, I add over, that's 12x equals 10. Divide by 12. Reduce, that's 5, 6. So x equals 5, 6. Let me show you again what I did. X has to be the denominator. So if I multiply that by x, it's gone. If I multiply that by x, it stays. Multiply it, disappears. And then I end up getting 12 minus 3x equals 2, because the x's are gone, plus 9x. Combine like terms, put that over here, put that over here. Divide by 12 and reduce x is 5, 6. That's how you do the addition and subtraction. So you have to have that common denominator, so you try to make things disappear. In my opinion, the multiplication and division is actually easier when you have these functions because you're actually making things disappear faster. Let me explain. X minus 9, x squared minus 9 equals minus 3, and x minus 3. Fraction equals fraction. Somewhere along the way, you're going to end up cross-multiplying. And so what I'm going to do is cross-multiply to get rid of the fraction. So this times this is x minus 9 times x minus 3 equals minus 3 times x squared minus 9. And you may think, well, why didn't you multiply through? Well, I see that x plus 3, x minus 3 is that, but I'm not dividing, so I can't reduce. Let's see if we do multiply through. Multiply through x squared minus 3x minus 9x plus 27 equals minus 3x squared plus 27. Put everything together, equal to 0, and so I'm going to subtract 27 over here, so actually the 27's go away. Add 3x squared, so that's 4x squared minus 12x. So if I want to solve that, I can take an x out of both of these. This is 4x minus 12. They both equal 0, so x equals 0. That's an easy one. And 4x minus 12 equals 0. Set that equal, move that over, so 4x equals 12 divided by 4x equals 3. And so I solved for both of them without a calculator. So I have two different answers. Okay? So cross multiply, got rid of my fractions. So I went ahead and multiplied through. Combine like terms equal to 0. And then I factored right here, take out an x out of both of them. And then I had 4x minus 12, solved them both, 0 and 3. I actually could have taken a 4x and worked it from there, but that would have done also as well. How would that have worked? Well, if I took a 4x out, then this would have been x minus 3 equals, so that's instead of all of this, so notice I have 0 and 3 as my answers. If I had 4x equals 0, x equals 0, then x minus 3 equals 0, and x equals 3. I got the same two answers. It didn't matter which way I did it. Okay, so let's try one more of those. Okay, multiplying and dividing. You're going to try to cross multiply to get that thing to disappear. So let's say you had 5y minus 3 over 6 equals 6y plus 2 over 8. I want you to solve it. That's usually what the word will say. But simplify means mark things out. Solve means you need an answer. So I'm going to cross multiply. So when I multiply here, multiply through, that's 36y plus 12. That's 40y minus 24. Combine like terms. I'll move this minus 36y to keep that positive. That's 4y. Add 24 equals 36. Divide by 4. Y equals 9, and so I got that answer. Why weren't there two answers? Because there was no squares in this. Since there was a square, there was two answers. Since it was only y to the first power, there's only one answer. Okay? So in addition to subtraction, you're trying to get common denominator, mark things out. When you have multiplication and division, so if this was division, okay, and that's fractions, which is division, get it out of fractions by cross multiplying, and you now get it into a multiplication form that you can combine like terms and solve. In the next video, you'll get a chance to try some of these on your own.